Today, we're talking about conjunction fallacy. It's people's tendency to assume that two events that are more likely to occur together than either event is to occur alone. The conjunction rule holds that the probability of both A and B cannot be higher than the probability of A alone. However, people's decisions usually violate the conjunction rule. Recent research findings showed that rats, like humans, were susceptible to the conjunction fallacy. There might be common underlying neural processes at play in both species' decision-making. Imagine you are in a Vegas casino and you're placing a bet on two different roulette wheels spinning at the same time. The chances of you getting a winning number on both is smaller than winning on just one, right? When you place a bet on the roulette wheel, each number on the wheel has an equal chance of landing. In a standard American roulette wheel, there are 38 numbers. If you place a bet on a single number, your chances of winning are 1 in 38 because there is only one winning number out of 38 possibilities. Now, let's consider the scenario where you are placing a bet on two different roulette wheels spinning simultaneously. The chances of winning on just one wheel remain the same, 1 in 38. However, to calculate the chances of winning on both wheels, you need to multiply the individual probabilities together. Let's assume each wheel is independent of the other. The probability of winning on both wheels simultaneously is calculated as follows: 1 in 38 multiplied by 1 in 38. This yields a probability of 1 in 1,444, or about 0.069%. The probability of winning on both wheels is significantly smaller than winning on just one wheel. This concept extends to many other situations in our day-to-day decision-making. However, we often overlook this simple rule of probability when we assume that unrelated events are somehow linked or that past outcomes will influence future outcomes. We are not taking into consideration the true nature of probability. This tendency to overlook probabilities can lead to flawed decision-making. For example, you are a physician and you need to diagnose a patient who presents a specific symptom. Let's call it symptom X. When faced with this situation, you are confronted with two possibilities. Option A, symptom X is the only symptom the patient has. Option B, symptom X is one among many other symptoms the patient has. Now, according to the rules of probability, it's generally more likely for a symptom to occur in isolation, which is option A, rather than as part of a broader set of symptoms, option B. This is because the occurrence of multiple symptoms is less probable than the occurrence of a single symptom. However, in an experiment, 97% of physicians violated this logical principle, falling into the conjunction fallacy. They assigned a higher probability to option B instead of option A. Even experts, people we place trust in, fall prey to this fallacy, and that can be alarming. The conjunction fallacy can arise due to mental shortcuts, such as availability heuristic or representativeness heuristic. Those biases can lead us to rely on specific, vivid, or easily accessible information when making decisions, even if it contradicts logical probabilities. Let's look at the conjunction fallacy in a professional setting. In your team, there is one team member named Joe who stands out as eloquent, confident, and always seems to have all the answers. Do you assume that Joe is the most competent person in the room? If so, you've just committed the conjunction fallacy. According to the rules of probability, the probability of someone having two distinct traits, such as confidence and knowledge, should be lower, not higher, than the chance of someone having just one trait. When we analyze the situation, it becomes apparent that confidence and knowledge are separate attributes that do not necessarily coexist in equal measure. It's entirely possible to meet someone who is confident but lacks substantial knowledge, or someone who is knowledgeable but is not confident. If you assign a higher probability to the combination of two traits, then you commit the conjunction fallacy. Imagine you are the CEO of a company. You have two key executives on your team, Adam, who is confident and charismatic, and Betsy, who is quiet but knowledgeable. Now you are faced with an important project that needs a strong leader. Who would you naturally lean towards? Many of us would be tempted to look for an Adam-Betsy hybrid, an executive who have both confidence and deep knowledge. The same rule of probability applies to the two traits of charisma and knowledge. The probability of finding a person who has both traits, charisma and knowledge, is actually lower than finding a person with either one of these qualities. This doesn't mean you should dismiss the probability of finding a charismatic and knowledgeable leader, but it does mean that the search may take more time and resources. When you think you found a perfect candidate, think again. So how can we combat this fallacy that seems so deeply rooted in our thinking? Start by paying more attention to the word "and." This tiny conjunction may seem innocent, but it can suggest multiple relationships and in turn cause us to misjudge probabilities. Consider this statement. We implemented programs X and Y, and the team performance increased substantially. It's easy to infer that both programs working together were responsible for the performance improvement. However, this inference may not be accurate. The truth is, it could be that any one of the programs contributed to the increase in performance, or perhaps neither program played a significant role. Instead of assuming a direct causal relationship between all the components connected by "and," we should explore other plausible possibilities and consider each factor independently. When making decisions, it's prudent to exercise a healthy dose of skepticism and critical thinking. Scrutinize the evidence, seek diverse perspectives, and avoid the conjunction fallacy. Start observing your decision-making process and those of others around you. See if you can spot instances of conjunction fallacy. Please feel free to share your comments below. Thanks for watching. I'll see you next time.